This is Learning Python Data Analysis, published by Pack Publishing. I'm Ben Hoff, and this is Section 2, Numerical Computing with Pandas. In this section, we're going to take a look at Pandas series and data frame, columnar operations using apply, grouping operations, working with date columns, merging operations, exporting data to JSON and CSV. Up to this point, we've been using the standard Python interactive mode, but for our Pandas discussion, we're going to switch to using IPython. IPython stands for Interactive Python, and it was built for interactive data science and scientific computing, which is exactly what we'll be doing. IPython has better defaults and tools for the terminal, such as autocomplete and good system function support. Since we've been less interactive up to this point, now is a good time to switch, as we'll be more interactive now that we've got data. So what is Pandas? According to the documentation, Pandas consists of a set of labeled array data structures. The primary data structures in Pandas are series and data frame. Pandas also has powerful tools to help with a lot of stuff, such as access indexing, aggregating and transforming data sets, date range generation, input and output tools, memory efficient data structures, and lots of other neat things. If none of those sound familiar, don't worry about it. We've got data and we're going to be manipulating it. Pandas provides us with some tools to do that with. So let's change into our code directory if you haven't already. So as you can see, I need to change into my code directory, and we're going to go ahead and activate our virtual environment, and then we'll change into our actual code, and then we'll change into our actual code directory, and then let's go ahead and fire up the IPython interpreter. So the first thing that we want to do is go ahead and import pandas as PD. Perfect. So now how do we read our data in? Well, we could do this using our SQL alchemy models and the session object, but Pandas provides several tools to work with SQL data directly. So let's use that instead. Specifically, there's three methods: readSQL, readSQL query, and readSQL table. The readSQL method is simply a convenience wrapper around readSQL query and readSQL table methods. A convenience wrapper, or function, if you've never heard of that term before, just means the function will try to smartly call the more specific or concrete function based on the arguments you pass in. So in this case, readSQL will try to call either readSQL query or readSQL table based on what you pass in. I'll demo both of these specific or concrete methods quickly. Just know that for any of these function calls, you could use the readSQL method. So for our first trick, let's go ahead and read all of our tweet data in using the readSQL table method. Now the readSQL table method takes two arguments: the table that we want to read in and the actual database URL. So the first thing that we need to do is, again, double checking to make sure that we're in the correct directory, because I'll be using a relative path. And if you aren't in this directory, what you need to do is use an absolute path instead. So the database URL is basically the SQL alchemy URL. So if you're going to use a different database or you're going to use an absolute path, make sure you refer to the SQL alchemy documentation to know how to do that correctly. But for us, since we're in the file, we'll just go ahead and pass in the relative file path here. Perfect. So now let's go ahead and we'll use the readSQL table method, and we'll pass in the table that we want to read, which is tweets, and the database URL. Perfect. Now, if you look at this function call that I just did, you can see I didn't assign this to anything, which I did on purpose. IPython's got a really neat tool that it actually stores the last result in the underscore variable. So since I didn't assign it, we can actually assign it right now using that. The other nice thing that it's got is we can also use, for example, if you need to get access to a previous result, say like from the column 3, or the return result from row 3, you can use the specific number. So since we don't want to overwrite our tweets data, I'll use _4. but that's also a way to get access to prior results, which is very useful when you're using IPython. So not all of our tweet data is family friendly, so we're going to drop the actual tweet information really quick, and we'll do that using the drop method, and we'll tell it the actual column that we want to drop, the fact that it is a column, and then we're going to pass in this in place equal true. So pandas, in order to prevent data loss, defaults to returning you a new object or result every time. So if you don't want that to happen, if you want to actually make changes, you have to pass in this keyword in place and set that equal to true like we just did. Sweet, so let's go ahead and grab our user table using the same method. So we'll say our users is equal to pandas read SQL table, and we want our users table, and we'll go ahead and pass in that database URL. So if we look at this data real quick, what we can see is some of our users are geo-enabled and some of them are not. So let's just go ahead and grab the users that have geo-enabled using an SQL query. So we'll say our geo SQL query is going to equal, we're going to select all the columns from our users where geo-enabled is equal to 1. Perfect. And then we can go ahead and say our geo-enabled users are equal to, and we're going to use, perfect. So we're going to go ahead and grab those users out directly. So we'll say our geo-enabled users is equal to pandas SQL, and this time we're going to use the SQL query method. So we'll go ahead and pass in our geo SQL query, and we'll also pass in our database URL. And now, if we check out those geo-enabled users, we can see that all of their geo-enabled are 1 or true. We can also do the above using pandas, and we'll cover how to do that in a little bit. Now that we know how to read our data in, let's talk about the data type or the result that we're getting back from the method. Pandas has two main data types, data frames and series. Series are one-dimensional data types, much like a list. Data frames are two-dimensional, labeled data types, much like a hash table, or in Python terms, a dictionary. So the two tables that we read in, our user table and our tweets table, are both data frames, and we can check this using the type method. As you can see, that's a data frame. So what kind of methods do we have for our data frames? Well, let's take a look at the pandas documentation real quick, which, by the way, is excellent. So here you can see the data frame, and you can see that the methods are all grouped by their broad category of things. So for example, all the attributes underlying data methods are grouped, and we'll cover this. We've got conversion methods, we've got indexing and iteration methods, we've got binary operator functions, functional application grouped by in window, computations, and descriptive statistics, and so on and so on. I would encourage you to peruse the documentation at your leisure. But right now, we're going to go ahead and explore some of these methods. So as I demoed earlier, the head method is a good way to look at a subset of data, specifically starting from the beginning. So if we want to grab out the first 5 tweets, an easy way to do that is using the method and passing in a number. And I guess it defaults to 5, I didn't realize that. But that's a good method if you're looking for that. So if we scroll up to this top of this data, we can see this first column, which is the pandas index, and we can see this ID. Now these look pretty similar. So for our data set, the ID is probably going to work fine as our index. So let's go ahead and make that happen right now. So go back to the bottom here, and we'll say tweets.setIndex. And we'll pass in the ID, and we'll pass in that in place equal true as well. So now if we do that again, if we pass in that head method, we can see the ID is our actual index that we're using. Cool, so let's go check out another couple of methods. So for example, there is the info method, which provides us a concise summary of our data frame. There's also the describe method. There's also the describe method, which provides us various summary statistics. Now, for this particular data member or data frame, this doesn't make a whole lot of sense since we don't really have numerical information for our tweets. But if you had a bunch of integers or floats or 64-bit information, you could definitely use this method to get some quick statistics. There's also the shape attribute, which will provide us with the dimensionality of our data frame. Along with that, we can get the individual columns, which I use quite frequently to figure out what's in here, as well as the index, which will show us our index ranges, which for us is just, again, our numbers. I've already introduced multiple times the head method, which is an easy way to grab out the first 5. There's also the tail method, which you can pass in a number to this as well to grab out, for example, the last 10 rows. For column access, we can access columns directly by calling the attribute that we're interested in. So, for example, tweets dot created at will work for us. We can get a series of all of our created at information. We can also use a dictionary style call. So for example, tweets created at will work as well. If we want to grab multiple columns, we can do that by passing in a list. So for example, let's grab out both our created at information and our user ID information. Perfect. So now you can see we've got both our created at information and our user ID information right there for us. For row access, there's a couple things we can do. First, we can slice. So if you're familiar with the slice index, we'll pass in the first index that we're interested in, such as the third index, and then the last index. And that'll go ahead and grab all those numbers out. We can also use Boolean indexing. So remember how I said I was going to show you how to grab only our geo-enabled users? Well, let's go ahead and do that. So we'll go ahead and set our geo-enabled users to none to make sure that we're actually doing something. And then we'll set those guys, our geo-enabled users, set this equal to users. And then to do our actual Boolean index, we want to pass in which column we want and a conditional. So we only want our geo-enabled users that are equal to true. And if we look at this data type, we can see we've got only So if we look at this data type, we can see, and specifically the geo-enabled, so if we look at that, the geo-enabled users, we can see that we've got all our geo-enabled is equal to true there. So the Boolean indexing is a really powerful method to actually go ahead and snag out just a couple of users. So the nice thing about this is we can actually grab multiple, or we can actually add multiple Booleans together. So for example, if we wanted to get our users that have both geo enabled and a friend count of greater than 50, we can actually combine these queries together. So we'll say users.geo enabled is equal to true, and users dot friend count is greater than 50. And we can go ahead and grab that information out. So that query is starting to get pretty long, and we have to use the parentheses to keep the statements separate. So let's shorten this up a bit and assign these conditionals to some variables instead. So let's create a variable that's called is geo enabled, and we'll set this equal to users.geo enabled is equal to true, and then we'll create another member which is has friends, and we'll set this equal to users.friend count is greater than 50, because that's the cut line for when you have friends or when you don't. And then we can just do this much more simplified now. So if we want to do the same Boolean indexing, we can just pass this in and say is geo enabled and has friends, just like that. Perfect. So it's an alternative calling style that is much cleaner than the one that we had before. So we can also use lock and ILock methods to get rows. Lock is for label-based indexing, while ILock is for position-based indexing. Now, since we reset our axis, this won't make much of a difference for this data set, but if our ID is incremented by 2 instead of 1, we'd probably want to use a label-based index, which would be lock, instead of a position-based index, which would be ILock. If you can't keep the difference straight, don't worry, that makes 2 of us. Just try them both and see which one actually grabs you out the data that you want. So we're just going to go ahead and use the lock data set. So users.lock, and we'll go ahead and grab out the 5th index. So you can see there we got our 5th index. And I don't think this makes any difference. We can check that out. Oh, it does. So if we do ILock, we actually get out, nope, the same information. Just kidding. So for our data set again, lock versus ILock doesn't make a difference, but if you're using a different index, it might be pretty useful. So either of these arguments to take multiple. So let's say you wanted to grab out both the 5th and the 20th. And you have to pass them in as a list like I've forgotten. Perfect. So now you can get access to both of those indexes. Sweet. So let's go ahead and take a look at our retweet count. So we'll do tweets.retweet count. That's interesting. All of our retweet counts are 0 for our tweets. What about favorites? These are 0 as well. What's wrong with all the tweet data that we created? Well, there's nothing actually wrong with it. The streaming API just doesn't include retweet or favorite information. So we'll have to get those values out on our own using the Twitter REST API. I'd encourage you to try doing this yourself using an OAuth handler, the API class, both of those are from the Tweepy library, and the statuses lookup method from the API class. Now, if you don't want to create this method and information yourself, no worries. I've gone ahead and actually done the hard work for you. So I went ahead and created a Python file right here called update tweets that'll actually handle this for you. So I would encourage you to try to knock that out on yourself because it's good exercise in coding. But if you're just interested in updating your information, you can call this using the from the command line using the update tweets file. So you can call this using the update tweets file right there. Perfect. So I'm going to go ahead and let that run, and then we'll come back in just a second.